Are we back? Members are out, but we can still wait as we go through the work. Unstable and stable, unstable and stable polymorphism. Therefore, when we are talking about these two forms, the main difference between them is that under stable, or which we call balanced, we shall have constant forms. Then unstable, we shall have, under unstable, we shall have one organism increasing in number, and another one, the other one, decreasing. The one will be increasing and another one will be decreasing. They are not in a stable state. Here, the environment is acting. Natural selection is acting. I have given an example of two peppered moth. When you go in an environment, in an area where we have industries like in here, Namamve, where we have very many industries, they produce a lot of smoke. Remember, we have two forms of peppered moth, the gray and the dark, gray or dark. Or we say the gray, they can call it non-melanic. You'll find books calling it non-melanic. And we also have the melanic one. Therefore, when the industries are set up, they produce smoke. The back of the tree, where these, remember, these moths will always habit the back of the tree. It's where they camouflage and stay. But now remember, industries are producing smoke. And when they produce smoke, the backs of the tree become what? Darkened. Therefore, the gray can no longer camouflage, and the dark will camouflage. It means this one, the dark is being selected before, and the gray is being selected against. The gray, if it cannot camouflage because the back of the tree is black and they are white, whenever they land on the tree, they are easily seen. They are eaten. Therefore, their population decreases. Therefore, this one population decreases. And the dark can easily camouflage. Therefore, they cannot easily be sighted by their predator. Their population goes on increasing. It means one form will increase and the other form will decrease. That is unstable, the transit. Any question about those two forms of polymorphism? I'm waiting. I'm waiting for the hand up or for the message.
So what are the effects of stable polymorphism?
The stable polymorphism.
What are its effects?
These polymorphisms, they don't have an effect. Their effect is to show that there are evidences of natural selection. They prove natural selection indeed is in existence. Behind it, there is natural selection. For them, they prove. Like how you can use sodium hydroxide to confirm copper 2 sulfate. It helps you to prove, to show you that there is copper 2 sulfate existing in a compound they have given you. Therefore, these ones are like confirmatory tests. They confirm to us. Yes? Because at the beginning, I told you we have finished natural selection. We are looking at now evidences. If you understood what is natural selection, we are looking at evidences of natural selection. Therefore, these are the evidences we are looking at to show that just indicating that there is natural selection taking place. One is polymorphism, the existence of an organism of the same species in two or more genetically different forms in a population. But we said it is of two types, stable and unstable. Stable, which sometimes can be called balance. The existence under here we shall say that it is the existence of an organism of the same species in two or more different forms, but in a fairly constant form, e.g. blood group, that A, B, O, and AB will always remain in a fairly state constant. Now, no one of them is being increasing beyond the other one. Sex, males and females, they are in a fairly constant number within a population. Then unstable, we said, is the existence of organisms of the same species in two or more forms genetically, in two or different forms in a population, with one form increasing in number while the other one decreasing in number, e.g. peppered moth. We are going to look, and you will understand that science of peppered moth mainly when we are looking at industry revolution in London. It is where it was explained mainly in under industrial revolution that before we had two forms of gray, moth and dark moth. The gray, which can either be called non-melanic, and the dark, which is called melanic. But when you set up industries in a given area, before it is the gray which is done what? Selected for. Because remember, before industries, the bark of the tree will be white. Because on the back of the tree, do you know what we call a lichen? Do you know an association called a lichen? Lichen, eh? It is always gray in color. Lichen is always occupying the bark of the trees. People who are in the village today, even if you're in town here, when you're moving around in the evening, try to look at the trees. Around the trees, you'll always find, back of the trees, you'll always find white punches. You can easily peel it off on coffee, mangoes. That is lichen. It is always gray. Now, before industries are set, the gray has a selective advantage because it will always camouflage, because the backs of the tree where the moths stay will always be gray due to the lichens. It means the gray moth will increase while the dark one will decrease because it cannot camouflage on the back of the trees where they survive, because the back of the trees are always gray in color, white. Now they can easily be identified and eaten. Therefore, their population decreases. But when industries are set up due to industrial revolution taking place, now those industries release smoke. That smoke will kill the lichens and darken the backs of the trees. The backs of the trees, which were gray, now they become dark. Now, when they become dark, it means now the gray moth will no longer camouflage, will no longer have a camouflaging advantage. Now, it is the dark which will have a camouflaging advantage. It means the population of the gray will start to decrease because now
you wear shoes.
They can easily seen. And in that process of easily being seen, it means they will be eaten and their population decrease. Now, the
dark come and put for shoes, you go. Come.
Will always have a selective advantage. Will always have a selective advantage. Now their population will increase because now they can easily camouflage. Have you understood the difference between stable and unstable polymorphism? If there is a question, ask before I leave for polymorphism. Okay, you write this question down. You write this question down. A, question A. Okay, I will give it to you at the end. I'll give it to you at the end. We look at another evidence. The first evidence we have looked at is polymorphism. We said how many evidences of Gundi do we have? Of natural selection, there are 5. We are going to look at all 4. Mainly, we are going to look at 4. We have looked at polymorphism. Now we need to look at what we call we look at what we call industrial. We need to look at what we call industrial melanism. We need to look at what we call industrial melanism. This thing we want to talk about, industrial melanism, is made up of 2 words. Industrial, from the word industry, then Melanism, from the word melanin. Now, under here, we are going to look at it. This thing occurred mainly. It occurs in very many regions where industries have been set. But it was first studied in London, in England, back in 1960s, when London had what we call, or England had what we call Industrial Revolution. They set up many industries during those years, which these industries used to produce or to produce smoke. Now, that smoke contained sulfur dioxide. That sulfur dioxide is a gas which kills lichens. I want you to follow me well. I told you lichens are, a lichen is an association between an algae and a fungi. It is a symbiotic association, but it is gray. Or if you don't call it symbiotic, you call it mutualism, mutualistic association. Therefore, those lichens are killed by sulfur dioxide. But remember, these lichens make the bark of the tree gray or white in color. Remember, we said we have two forms of peppered moth, the gray and the black. Put that, or the dark. The gray, which we call non-melanic, and the dark, which we call melanic. Now, it means if the barks of the tree have a lot of lichens, it means they are gray. Which of the two will have a selective advantage? I need an answer. Which of the two will have a selective advantage? Which of the two will have a selective advantage? The gray or the dark? No one is replying. Which one of the two will have a selective advantage? The gray or the black? When the barks of the tree
Okay, sir.
Yes.
Now you said where there are industries, the black will have a selective advantage.
I have told you, listen to my question. Don't set your question.
Okay.
I said at this point, I have not yet brought in that issue of industries or what or no industries. I'm saying the bark of the tree possesses lichens. It means it is gray because the lichen is gray. Of which of the two will have a selective advantage? The gray peppered moth or the dark?
The gray.
The gray, because it will have easily camouflage.
The gray.
The camouflage. That one will happen before industries are set in. It means before industrial revolution, the gray peppered moth will have a selective advantage and the dark will have no selective advantage. Therefore, the gray population will rise and the dark population will decrease. But during 1960s, when England had what we call industrial revolution, the massive setting up of industries, the industry started to produce smoke and sulfur dioxide, which sulfur dioxide killed the lichens, and the smoke made the tree, the bark of the tree, painted the bark of the tree darker now during the Industrial Revolution. Therefore, the bark of the tree became dark. Therefore, changing the selection favor. Therefore, the dark or the melanin, the dark or the melanic peppered moth attained a selective advantage. And the other ones, the gray now became selected against. It means their population increased. The population of what? Of the dark increased and the population of the gray decreased. That is what we call industrial Melanism. Therefore, in simple terms, what is industrial Melanism? In simple terms, what do we refer to as industrial Melanism? When we talk about industrial Melanism is evolutionary process. Why do we call it evolutionary process? Because remember, it has favored the dark population is increasing. Industrial Melanism is evolutionary process that increased or that resulted, that we are talking about what we refer to as industrial. We are looking at the definition of industrial Melanism. When we talk about industrial Melanism, we are going to see that industrial Melanism, in simple terms, industrial Melanism is under industrial Melanism. We are going to see that industrial Melanism is evolutionary process. Is evolutionary process. Is evolutionary process that resulted into increase in frequency. When I say frequency, I mean number, total number, frequency of melanic type. The melanic is the dark. More than the melanic type, more than the light, all the non-melanic peppermint in a population. That is what we call industrial Melanism. Industrial Melanism is evolutionary process. It brought about evolution. At the end of this topic, you will be able to bring about this knowledge together and you will understand evolution. Whenever the frequency of one species, when I say frequency of a given of a given type of species increases, it means there is evolution. It is being favored, it is changing. Therefore, this is what we call industrial Melanism. That's why we call it evolutionary process, because it resulted into formation of the melanic form of peppermint. It is believed, one thing you need to know, it is believed that the melanic form was not into existence before. What do I mean? Before industrial Melanism revolution, before industrial revolution, setting up of industries in England, we had, it is believed that we had only one type of peppermint, which was gray. Because the dark would not exist because it was selected against. We had only the gray. But when industrial revolution came, when industrial revolution came, the backs of the trees were painted black. Now this gray started to mutate, changing. It did not happen in 1 year. That's what I want you to put in your head. When I say changing, that change did not take place in 1 year. It took years. Then it went on changing. We go to the gray, we go to the dark. Now its population increased rapidly because it was favored, because it could not easily be predated on. It could easily camouflage due to the shoot from the industries, making the backs of the tree black or dark. That's what we call industrial Melanism. The evolutionary process which resulted into increase in the frequency of the melanic type of moth more than the light one. because the light one was selected against due to the barks of the tree turning dark. Hence, their population decreasing because they would easily be predated on. They could not easily camouflage like the melanic ones. Have you understood what is industrial melanism? Yes?
Yes.
Now, it means industrial melanism rose or came as a result of mutation. The gray peppered moth mutated, went under mutation. You will understand mutation when we go to genetics. Mutation, genes change, environmental factors, the selection pressure causes the genes to change. When the genes change, we get a different form. Are you seeing how we get a new species now arising? From gray, we get the melanic one. Due to the genes changing, the genes of the gray changed, now we got a new form. Now, the new form, which we call the melanic, found that the environment favored it. Therefore, industrial melanism comes from mutation. It's the mutation which starts the process. If it was mutation, the gray would not mutate. It would just extinct and we could not get what? We could not get the melanic, the dark or the melanic peppered moth. But due to environmental conditions changing, predation increasing, what environmental condition is here? The environmental condition I'm talking about is predation. Predation increased. How did it decrease? Because we said during Industrial Revolution, the barks of the tree were painted black. Were painted black or dark. It means predation pressure increased on the gray peppered moth. Now it means the genes of this gray started changing, mutating, which after a given period of time, a long period of time, we got a gray peppered moth, a dark peppered moth. It means a new species evolved due to mutation as a result of natural selection causing it. Now, mutation occurred. When the mutation occurred, what happened? We got a new character. And when a new character existed, it means we have evolution taking place. Therefore, a question can come and say, what is industrial melanism? That is A. I'm going to give you this question. Then another one asks you to describe industrial melanism. To describe industrial melanism. Therefore, you say industrial melanism arises due to mutation, whereby during Industrial Revolution, the barks of the tree, we shall see, the barks of the tree were painted black, resulting into the gray peppered moth mutating. Since it was selected against, it did not have a selective advantage. It mutated, giving the dark, the black moth. Therefore, in this case, we shall look at that. The black would easily camouflage to avoid predation compared to the gray one. Therefore, camouflaging provided a basis onto which the gray peppered moth was selected against and the black was selected to survive than the white one. Therefore, we shall look at that and have a question and go through it. But hope you have understood what industrial melanism is all about. Yes? Now we go to another one, which we call another evidence, which we call drug stroke pesticide. It can either be drug, someone can call it pesticide, someone can call it antibiotics. antibiotic resistance. Antibiotic resistance. You know why sometimes when you go in the hospital, doctors tell you to avoid using a lot of antibiotics, drugs, because whenever you overuse them, the pathogens, the pathogens get done what? The pathogens get adapted to it. Drug, pesticide, either it can be drug, it can either be called drug, either pesticide or antibiotic resistance. But the important thing is the word resistance. Under here, we are going to see that, you know, drugs kill pathogens. Like you have chloroquine killing Plasmodium. Pesticides kills pests. Like you can use some DDT to spray caterpillars, mosquitoes, to kill. Those are some of the pests. Then antibiotics, fungi like penicillium, killing fungi. But what you must know, those pathogens like fungi, bacteria can get resistant to diseases. That's what I want you to know. Like an example, these days, an example I can use like for drug is chloroquine. For us, by the time we are young, whenever you could suffer from malaria, they could give you chloroquine, and 1-2 days you're okay. Chloroquine and Fansida. But some of you have not even heard of such drugs, chloroquine and Fansida. Because as the human beings kept on using that chloroquine and Fansida, the Plasmodium parasite became resistant to it. That's why currently, when you get malaria, the Plasmodium parasite in your body, and you swallow, even if you swallow 10,000 tablets of chloroquine and Fansida, you cannot cure from malaria. They will just kill you because of overdose, but they can no longer kill that Plasmodium parasite because it got adapted. Now the question is how they get resistant to those diseases, those chemicals which we are killing them before. How do they get resistant to them? We are going to see it is due to mutation. We are going to talk about that. But what I want you to first recognize or to first appreciate is that these pathogens, these bacteria, these fungi, these viruses can get resistant to a given drug, to a given pesticide, to a given antibiotic, if you use it for a long period of time. That shows natural selection is in existence, because they will get adapted and get favored by the environment. Even if you spray using a pesticide, the mosquitoes will no longer die. They will no longer die because now they are adapted. They have been selected before. They have got adapted. Now they get selected before. It shows there is natural selection existing. Drug, pesticide, antibiotic resistance. What now, by definition, what do we call it? They can use any of the words. They can say what is drug. Another one can say pesticide. Another one can say even insecticide resistance. Another one can say antibiotic. That's why I've written all of the three. So that when they ask one of them, you don't say that the teacher taught us drug, but he did not teach us insecticide or pesticide. They are the same. The way they arise, they're the same. Therefore, when we talk about this drug, pesticide, antibiotic, insecticide resistance, the important word is resistance. Therefore, this is, in simple terms, when we talk about that, our time is running out. We need to quickly move and we see. Now, this is where Because we said, first of all, how does this resistance come about? It is by mutation. When you keep using a drug on a given pathogen, when I say pathogen, I mean for you call them germs. That is primary science. Pathogens, those pathogens like Plasmodium, when you keep using a drug on them, these pathogens develop an enzyme. They mutate, and mutation results them to synthesize an enzyme, which enzyme we call oxidoreductase enzyme. We call it oxidoreductase enzyme. Reductase enzyme. That enzyme makes the drug harmless. It will make it harmless. It will oxidize it or reduce it to make it harmless. Something which we used to kill the pathogen. Now, because now that pathogen has developed an enzyme which we call oxidoreductase enzyme, that enzyme will either oxidize, rendering that drug harmless now. Therefore, it will survive. It means resistance, what you have to put in your head, that resistance of these drugs arises as a result of mutation in these organisms. Mutation, you need to appreciate that. Therefore, it is mutation which brings about resistance in pathogens. Therefore, when a mutation occurs, not all organisms will mutate at once. We shall have those ones which have mutated, which we call mutants, mutants, and those ones which did not mutate, which we call the non-mutants. Now I'm going to ask a question. On these two organisms, the mutants and the non-mutants, which one will survive? Which one will survive the drug? The mutant or the non-mutant? Please answer quickly and we go.
The mutant.
The mutant will survive.
The mutant.
The mutant.
The mutant.
Okay, fine. The mutant will survive because it has mutated and has got an enzyme which we call oxidoreductase enzyme, which breaks down the drug. Immediately you take the drug, it will be broken down. And when it is broken down, it means it cannot kill this. Therefore, the non-mutant, for them, they will die. It means this mutant will be selected upon, will be selected for, and the non-mutant will be selected against. It means a time will come when we only have mutants, while the non-mutants have failed to, will all die. Have you seen how mutation has occurred? We have got a new species which was not there before. The mutant is a new species. That's what we call evolution. That's what we call evolution. It has occurred. Therefore, these ones, but evolution has come as a result of natural selection. Nature selected against the non-mutant, and these ones, the mutants, we are selected for. Because we know under natural selection, we have one being selected for and another one being selected against. Have you understood that? Therefore, when we talk about drug, pesticide, antibiotic, insecticide resistance, this is whereby the mutant type of a pathogen develops resistance towards a given either drug or pesticide or antibiotic, which fails to kill it in a normal way as it was killing it. Have you understood that? That this is where we are saying this is whereby the mutant, we are giving a definition of drug pesticide resistance. This is whereby the mutant type of bacteria, or you can say pathogen, you can say bacterial pathogen, pathogen, develop resistance towards towards either it can be towards a drug, or it can be a pesticide, or it can be antibiotic, which fails to kill it, the normal way. E.g. chloroquine and fancida when it comes to plasmodium parasite. The plasmodium parasite mutated, changed. It means it evolved. The one we have now is different from that one which was there in early 2000. Now someone will say, Master, you told me a generation cannot live to see evolution occurring. Yes. But remember, these ones, the reason why we can see it can happen in one generation is because these pathogens are simple. They are unicellular. They are simple organisms. They can easily evolve. Complex organisms, you cannot live to see evolution of a complex organism. Like human, like a monkey, like animals. Okay, animals and plants, you cannot. But these unicellular organisms, they can easily be, their evolution can evolution can occur in them easily because they are simple. They don't have complex systems and organs which need to change for evolution to occur. But these ones are simple. Therefore, the plasmodium parasite we had in early 2000s is totally different from that one we have now here in 2021. It's different because it mutated. Have you understood what we call drug, pesticide, antibiotic resistance? Now, from there, we see how it arises. Someone can say, explain how resistance arises, drug resistance arises. The first thing you need to know that we have said drug resistance arises as a result of mutation. It is mutation which brings about that resistance. That is the first statement you need to write when someone says, describe how resistance to drug arises, or describe drug resistance. Therefore, resistance occurs by mutation, which produces, therefore, mutation produces a mutant strain, which mutant strain contains an enzyme which we refer to as oxidoreductase enzyme. Which oxidoreductase enzyme will deactivate or break down the drug when you take the drug. Therefore, this mutant becomes resistant. While the non-mutant organism will die, and therefore it will not survive. It will not survive. Therefore, that is what we refer to as mutate. That's what we call the drug resistance. How resistance in the drugs arises. It arises, therefore resistance arises occurs by mutation, producing a mutant strain, which mutant strain contains an enzyme, which we call oxidoreductase enzyme. That enzyme, oxidoreductase enzyme, will always break down and make the drug less harmful. Therefore, it can no longer kill the pathogen, causing it to survive. Then the non-resistant strain will be killed and will be selected again.